The data comes in like whispered heresy, a calm disk of starlight sweeping one way while its gas streams the other, spiral arms pointing forward when nearly all others trail behind like smoke. Telescopes blink, spectrographs hiss, and somewhere in the control room someone says what everyone is thinking. This should be impossible. A galaxy that spins the wrong way is not a mere curiosity. It is a scar. It is a confession. It is a clock that was taken apart and reassembled with one gear flipped. And now every tick exposes how fragile our story of cosmic order really is. Watch the luminous river of stars. Their orbits agree on a direction, a collective memory etched over ages. Now, look at the gas. Cold, extended, whisper-thin, flowing against the stellar tide as if the galaxy were breathing in and out at the same time. In some cases, the rebellion is subtler and stranger. The spiral arms lead instead of lag, the tips of the swirls pointing into the headwind, a corkscrew that winds into the future instead of out of the past. Stand on a dust lane at the disk's edge, and you would see traffic moving both ways on the same celestial highway, each lane carving a different history into the night. You expect the universe to choose a side. It rarely does. Wrong here is not a moral charge, but a map notation, a red underline in the ledger of angular momentum. A disk rotating opposite to its gas, a core spinning contrary to the suburbs of stars around it. A majestic ring crossing the main body like a polar orbit, its young clusters blazing on a path almost perpendicular to the old city of light. These are not accidents. They are fossils of collisions, testimony from captured gas, and signatures of torque reversals so profound that a galaxy's long habit of motion was interrupted and told to turn. Picture the usual tale we tell. Clouds collapse, gravity squeezes, and like a skater drawing in their arms, the forming galaxy spins faster, settling into a disk with arms that trail the rotation. Order from chaos, a single direction from a swarm of possibilities. The wrong way galaxy is the witness who steps into the courtroom and contradicts the script. It says a different story unfolded, that after the first spin was chosen, something hidden was waiting in the dark. An encounter or a stream or a misaligned river of the cosmic web. And it fed the system with momentum pointing the other way. Imagine growing a skyscraper in the Stone Age. Unlikely, yes. But if you find one, you learn that a different civilization touched this ground. Listen closely to what the light is saying. Stars wear the ages in their spectra. Gas whispers of shocks and shears in the lines it emits. When the two disagree about direction, you are watching a negotiation. At the interface where opposing flows meet, clouds collide, compress, and ignite. A ring of fire blooms. The galaxy turns its contradictory motions into newborn starlight, as if the very disagreement has to be burned into clarity. You can almost hear it. The hiss of infall, the low drum of gravity, the flare of birthing clusters along a boundary drawn by physics and chance. For you, watching from a pale world on the outskirts of an ordinary spiral, this is more than spectacle. It is a reminder that nature keeps experiments running at scales beyond any laboratory. Wrong-way systems are natural experiments in angular momentum, galactic wind tunnels, cosmic colliders, pinwheels with reversed blades. Each one is a notebook full of scribbles about how galaxies really grow. By sipping long filaments, by swallowing small companions, by being yanked and twisted by neighboring masses until their inner parts forget the old oath and swear a new one. What you are about to see will change how you think about the universe. Not because everything you learned was false, but because the simple story was only a prologue. If you have ever spun a coin and watched it precess and wobble as it slows, you know the feeling of a system declaring that small nudges matter. Now scale that intuition to a city of stars. A single misaligned stream can rebuild an entire outer disk. A single past encounter can seed a core that turns opposite the suburbs. A set of arms can lead the dance instead of follow, and in their defiance, reveal how gravity choreographs from both history and happenstance. In this light, a wrong-way galaxy is not broken. It is bilingual. It speaks in the accent of its birth, and in the dialect of everything it has survived. The outer gas remembers a captured cloud drifting in from a skewed filament. The inner stars remember a steady youth under a calmer sky. Where their memories overlap, new clusters are minted, heavy elements are rearranged, and the shape of the disk learns to carry both stories at once. If you trace the dust lanes, you can read the palimpsest of that compromise. Warps where the halo's hand is pulling, knots where the bar has twisted the flow, luminous stitches where shocks bind the disagreement into rings. You can stand with the astronomers in that first breath of disbelief. The velocity field on the screen looks like a weather map predicting a storm that already happened. Blue where it should be red, red where it should be blue, a swirl that leads instead of trails. The room is quiet, then charged, because everyone understands the stakes. If a galaxy can reverse what seemed ordained, then every tranquil disk might be a calm between reversals. Every spiral arm might be a signpost, planted by an ancient gust. Our own Milky Way hides warps and streams that whisper a similar language. If you feel a chill, it is the wind of perspective. The cosmos is less a machine and more a negotiation, and even the most faithful rotors can be convinced to turn against their past. For more content, like the video, subscribe, and tell me where you are watching from. But when you ask why the spin turned, you step across a threshold, and on the other side waits the origin of motion itself. The first tug, the first twist, the first choice made by matter when the universe was young. And that question does not loosen its grip.
The simulation lights flicker, and a young universe blossoms across the screen like frost racing across glass. You feel the first motions as faint ripples, not yet storms, gravity tugging on gravity, small overdensities pulling on their neighbors with a patience that could erode mountains. Watch closely. Nothing explodes into order here. It is coaxed. It is twisted. It is taught to turn. In those infant epochs, when matter was a hushed mist and light still wrestled with fog, clumps of dark mass gathered like silent architects. Their shapes were not spheres but bruised ellipsoids, lopsided and full of intent. Nearby, other clumps drifted, and the crosswinds of their gravity added a sideways pull, the kind that takes a falling raindrop and curves it into a spiral. These are tidal torques, the first hand on the first wheel. They do not shove, they lean. They nudge a would-be galaxy into a slow pirouette, and that pirouette becomes a habit written into the halo that will cradle everything to come. Gas, still warm from the fire of creation, cools like breath on winter air and sinks toward the dark skeleton. It does not plunge straight down. The inherited spin asks it to circle, and circling saves it from collapse. Think of a skater extending their arms to slow and drawing them in to turn faster. The disk being born performs the same quiet physics. As the gas settles, it flattens into a luminous sheet a few 100,000 light-years wide and only a whisper thick compared to its span. Through this sheet, spiral patterns whisper outward like pressurized ripples on a drum. Not solid pinwheels, but waves of density that herd stars and clouds as they pass. Here is where your eye can read direction. In a normal spiral, the pattern trails the motion, the arms swept backward like hair in a steady wind. This trailing is not decorative. It is the outcome of orbits nested inside orbits, inner rings overtaking outer rings, a concert where each instrument keeps its tempo while the melody raps backward along the flow. The arms are not rigid bridges. They are traffic jams written into the stars, places where matter slows and crowds, and then thins again, all of it moving with the rotation while the pattern lags a step like a chorus echoing the soloist. Now step back to the larger map. The cosmic web is not poetry, but it reads like it. Filaments crossing filaments, rivers of gas pouring along invisible valleys carved by dark matter's gravity. Protogalaxies do not eat from every direction at once. They drink from these rivers. And those rivers carry not only material but memory. a net angular momentum that tends to agree with the spin already etched into the halo. Over billions of years, the steady supply reinforces the original twist, the way a prevailing wind trains a forest to lean. A galaxy fed by a consistent filament keeps its heading. A disk raised on one flavor of momentum adds layer upon translucent layer of stars, all moving in the same graceful sweep. Inside the disk, other sculptors work. A bar may emerge in the central regions, a bright wooden beam across the face of the city, stirring orbits into elongated loops that trade angular momentum the way dancers trade partners. Spiral density waves roll through and reorganize the crowd. Supernovae punch hot cavities that later cool and flow back. Black hole outbursts push and pull. These are local unions and divorces, energy budgets balanced and rebalanced. Restlessness that thickens the inner regions and nudges gas across resonances where it lingers and forms new clusters. The net spin remains faithful, a compass that points the same way even as streets get rerouted. You can see this choreography in the chemistry as well as in the motion. Stars born early in the disk carry fewer heavy elements, fossils of the young cosmos when metals were rare. Younger stars, forged from gas enriched by many cycles of birth and death, glow with a higher metallic accent. The gradient often flows cleanly from poorer outer neighborhoods to richer inner quarters because inflow, rotation, and star formation work together like gears. The metallic handwriting aligns with the kinematic story. Long-term coherence, a city layered by epochs yet anchored by a single preferred spin. When the halo breathes, the disk answers. Minor flutters of the dark mass cause warps at the outskirts, subtle tilts like a vinyl record heated at the edges. But the alignment between halo spin and disk spin tends to recover, guided by torques that act over timescales beyond any human patience. Imagine a lake with a slow current and a thin wind. The ripples are temporary, the overall flow steady. In this equilibrium, misalignments are whispers that fade. Reversals are rare, because to turn a rotating city of stars you must do more than shout. You must import a new history and insist it be heard. The statistics tell a quiet story. Where interactions are scarce and the environment is calm, disks behave like well-trained gyroscopes. They precess, they wobble, they flare, but their sense of direction endures. A galaxy far from meddling neighbors and untroubled by strong external streams wears its rotation like a long, unbroken oath. Even the bar that torques the center or the feedback that stirs the gas do not commonly flip the sign of motion. They redistribute the budget rather than rewrite it. The preferred axis may tilt with time, but the hands on the clock still move the same way. All this fidelity births confidence. Astronomers build models that assume consistent spin, and those models succeed often enough to feel like truth. They predict trailing arms. They match the thickness of disks after many cycles of star formation. They anticipate how gas infall will settle, how bars will funnel material inward, how outer rings will flare under gentle tides. When a galaxy adheres to these expectations, it becomes a reference point, a baseline that makes the sky legible. And yet, in the hum of agreement, you can sometimes hear a dissonant note. A halo might couple to a filament that slowly wanders in orientation. A quiet neighbor might hide a history of close passes. A dark substructure might tilt the balance in a way that does not announce itself in light. Habit can be loyal, but it is not invincible. A single river flowing in from a skewed direction can undo 1 billion years of reinforcement if it persists long enough or arrives with enough mass. The gyroscope that seemed unflippable begins to nod, not theatrically but inexorably, until the disk must choose between memory and momentum. You feel it as a question that presses on the ribs. How many nudges does it take to persuade a galaxy to betray its past? And what would the night sky look like at the moment that persuasion starts to win? The control room dims, and the galaxy on the screen breathes in false color. Sapphire on one side, ember on the other, like a lung cycling through light. You can hear the whisper of data turning into wind. Starlight stretched when it flees, squeezed when it approaches. This is not guesswork. This is the Doppler truth. One hemisphere arrives slightly bluer, one slips slightly redder, and the whole disk reveals a hidden arrow, a direction of motion etched into wavelengths too fine for the eye but impossible to silence. If you have ever listened to a siren pitch shift as it races past, you already know the language. Space sings the same song, only with stars for sirens and centuries for moments. Now the map sharpens into a mosaic of tiny spectra, each spaxel a fingerprint of motion. Integral field spectrographs carve the galaxy into thousands of adjacent windows, measuring not only brightness but velocity at every point, like laying a stethoscope across an entire city and hearing the traffic flow. The result is a two-dimensional river chart, blue for the shore that comes toward you, red for the shore that pulls away. When the colors reverse across the centerline, rotation stands confessed. When they twist, kink, or fracture into islands of contradictory flow, something stranger has taken the wheel. Gas tells its tale loudly. Ionized regions around newborn stars glow with emission lines that stand up like bright reeds in the spectrum. Astronomers read their spacing to the fraction of a whisper and trace the currents. But the loudest storyteller is colder, farther, older. Neutral hydrogen radiating at the 21-centimeter line, a radio heartbeat that keeps time with the outermost disk where starlight grows thin. When dishes and arrays tune to that line, the visible face of the galaxy gives way to a radio skeleton. Warps that hide in optical light unfurl with clarity. Extended arms, pale as breath in winter, become bold lanes. If the outer gas has flipped its allegiance and now circles opposite the inner stars, the 21-centimeter map will not hedge. It will print the reversal like ink drying on a confession. Stars speak more softly, but they are legion, and their combined voice can be separated from the gas. In the spectrum of a stellar population, countless absorption lines shift together, a subtle mass choir leaning slightly blue on the coming side and slightly red on the retreating side. By fitting models to this forest of lines, astronomers lift out a stellar velocity field, the movement of the older city beneath the neon of the gas. Overlay the two, and you see whether age and youth agree. Agreement means long peace. Disagreement means a history of encounters that left fingerprints on the wheel. Light does more than carry motion, it sketches geometry. The dust lanes that stitch across a spiral's face serve as depth cues, like shadows in a painter's study. On the near side of a tilted disk, dust veils the inner edge of an arm more heavily. On the far side, the dust lies behind the bright stars and the arm looks cleaner. Once you know which side is near, the winding sense of the spiral, the direction the arms curve relative to the center, tells you whether the pattern leads or trails the rotation. Trailing arms, the common case, hook backward against the motion. Leading arms, the rare rebels, point into the oncoming flow. No stopwatch is needed. The dust and the draw of the curves reveal the choreography. There is another quiet testimony hidden in polarization. Starlight that scatters off dust grains is gently polarized, and the magnetic fields threading the disk align those grains like iron filings. Map the polarized signal, and you map the magnetic scaffolding that has been stretched by rotation and shear. Where gas streams reverse, fields twist and fold, and the polarization vectors mark seams like stress lines in tempered glass. These lines do not tell you speed in kilometers per second. They tell you history, how long the tug of one direction has been working, how recent the intrusion of the other might be. Chemistry joins the interrogation. Accreted gas captured from a small companion or a wandering filament often carries a different metallic makeup than the native reservoir. If an outer disk has been rebuilt by infall from a misaligned stream, the metallicity can dip outward in a way that does not match steady, inside-out growth. Spectra of star-forming regions along that outer ring will register the difference, a chemical accent that betrays foreign birth. Where counterflowing components meet, shock fronts can light up with enhanced emission from excited atoms, luminous handwriting at the border of disagreement. Kinematics alone can be tricky if the disk is nearly face-on or badly warped, so astronomers triangulate with everything the galaxy will surrender. Velocity fields, dust geometry, arm winding, polarization, stellar populations, and the faint glow of outer hydrogen. In an early type system where a neat disk is hard to see, central absorption features might betray a kinematically decoupled core, an inner city turning opposite to its suburbs. In a polar ring, the contradictions are exuberant. One component wheels almost perpendicular to the other, and the velocity maps cross like blades. Even there, the near-side test with dust and the subtle brightening on the closer rim help fix which direction is up and which way the traffic runs. None of this is a single switch labeled right way or wrong way. It is a bundle of clues that must agree under pressure. A slight misalignment could be a warp settling. A sharp reversal needs a more violent cause. The task is to separate a tilt from a betrayal. That is why observers love redundancy. If neutral hydrogen claims an outer flip, and the ionized gas shows shear at the interface, and the stars remain loyal to the original spin, and the dust lanes place the near side where the colors demand, then the story stops being a hunch and starts being a verdict. You can feel the risk and the thrill in the room when a new target pops onto the screen. If the hues are symmetrical and the dust lanes behave, hearts slow. When they do not, when the blue bleeds into the wrong quadrant and the red stains the other, when the arm curvature refuses to match the expected flow, a hush settles that feels like the moment before a storm breaks. Instruments do not gasp, but people do, because they know they are not just measuring speeds. They are catching a galaxy mid-confession, and confessions have consequences that ripple out past the frame. The picture sharpens and motion turns into motive. You are not just watching a disk rotate. You are reading the pressure marks left by encounters that bent its will. To reverse a habit this vast, the universe reaches for a few brutal instruments and a few exquisitely patient ones, all of them working on the same currency, angular momentum. Imagine a city whose roads are all one way, and then imagine a caravan arriving that insists on driving against the flow. The traffic pattern changes, not by debate but by mass and insistence. First comes the quiet ambush. A smaller companion approaches on a retrograde path, fainter than the host and easy to miss against the starry crowd. Its stars and gas are not empty symbols. They carry their own spin like a passport with a different script. When tidal arms unfurl and the companion is pulled apart, its material rains down along orbits that circulate against the host's established direction. The stars from this minor invader settle into a thin, cold lane that does not match the native drift. The gas spreads wider, colliding, losing energy, and forming a counter-rotating disk that slides like silk laid over wool. Where the two flows touch, shear sharpens into shocks. Clouds compress. A ring lights up with newborn clusters that trace the fault line like embers on the edge of paper. You can point to that ring and say, the argument became stars right here. Sometimes the courier is not a galaxy at all, but a river. The cosmic web does not politely ask a halo which way it is spinning. Filaments pour what they are carrying. If a halo that has long been fed by one filament taps a different vein with a skewed orientation, the sign of delivered angular momentum can flip. Cold gas, barely warmed by its fall, dives in along a plane that cuts across the existing disk like a blade. Because gas can radiate away the heat of collision, it settles more quickly than stars can adapt, building an outer disk whose sense of motion contradicts the old inner city. You read the chemical accent in this new material. Lower metallicity than the enriched native reservoir, a cooler palette, gradients that bend in ways an undisturbed history would not write. Over time, star formation in the new lane populates it with youth that orbits the wrong way with perfect confidence, as if the neighborhood had always been theirs. There is a more theatrical misalignment that takes no pains to hide. A polar ring is a luminous oath sworn at right angles. A core galaxy holds its posture, while a captured gas-rich stream circulates nearly perpendicular, raising a bright ring or even a full secondary disk that wheels like a tilted halo. The geometry is not a parlor trick. The kinematic axes cross like swords in the data. One set of velocities sweeping east to west, the other north to south, both insistent, both coherent. Gravity does not mind the audacity. Over many orbits, the ring can grow massive and stable, its star-forming knots paving a roadway that loops above the host. Seen edge on, the structure looks impossible, a luminous hula hoop threaded through a city of stars. Seen in motion, it is a compromise the halo knows how to keep. Not all reversals arrive from outside. The heart of a galaxy can pivot against its outskirts under the grip of a bar. Bars are engines that move angular momentum around, borrowing from one set of orbits and paying another. Gas on nearly circular paths can be torqued inward along bar lanes until it piles up near resonances where the rules of motion change. In those cramped quarters, nested orbital families cross and exchange energy. With the right nudges and the right inflow sequence, an inner disk can decouple kinematically, carving out a core that spins in the opposite sense. The stars there are not interlopers from a foreign town. They are locals whose routes were rewritten by the bar's relentless bookkeeping. Observers call the result a kinematically decoupled core, but the phrase hides the drama. You are watching a city center declare its autonomy, while the suburbs keep their creed. Clusters add another kind of switch. A spiral plunging through hot intercluster medium at high speed experiences ram pressure, like a headwind strong enough to tear banners from poles. Gas is stripped from the outer disk, peeled away into a wake that glows in soft X-rays and H-alpha like a wound. The stellar disk remains, spinning by habit but starving. Later, in the eddies behind the stripped galaxy, or in the cluster's outskirts, that same gas or gas from another source can be reaccreted along paths that do not match the original orientation. The hungry spiral drinks what it can get. A new reservoir forms in the opposite sense, and with it a chance for fresh star formation, shocks at the interface, and a flip in the sign of the living disk while the old stellar backbone remembers a different anthem. Even a flyby can matter if it is timed like a picked lock. A close pass deposits torques that twist the outer orbits and warp the disk into a long-lived tilt. If, in the aftermath, the galaxy taps a filament whose direction does not coincide with the tilted plane, the accrued misalignments can cascade into a full reversal in the outskirts. In this way, small agitations write large consequences, like a steady crosswind that takes a river and persuades it into a new channel mile by mile until the old bed dries to memory. All these mechanisms share a single script beneath the spectacle: exchange and reallocation of angular momentum under gravity's conservative rule. Nothing is created from nothing. Spins are borrowed, stolen, traded, and reoriented until a new equilibrium emerges that looks like rebellion only because we are reading it from the vantage of the past. Yet even when a new order forms, the scars persist. Warps linger at the edge where the halo's preferred axis keeps tugging. Velocity dispersion rises where past shoves heated the orbits. Thick disks inherit the rumble of previous arguments, and rings mark past negotiations sealed in stars. You can stand in front of any of these systems and feel the same double pulse: the steadiness of rotation and the unease of how it came to be. Every counter-rotating lane, every polar loop, every decoupled core is a verdict reached by mass, momentum, and time. And still, a question stalks the light like a shadow at noon. When multiple roads lead to reversal, how do you tell which hand turned the wheel? The doors of the archive swing inward and the lights settle on a sequence of defendants, each carrying a different scar and each daring you to read it correctly. These are not sketches. These are depositions taken in starlight, velocity fields sworn under oath. One after another, the screens ignite with evidence of how a galaxy can be persuaded to turn against its own memory, and the room grows quiet, because every case says the same chilling thing in a different accent. Habit yields to history. First onto the stand is NGC 4550, a lenticular in the Virgo country, outwardly modest, inwardly divided like a city with two governments. Lay the stellar velocity map across its face, and the contradiction leaps up like a double signature on the same line. Two stellar disks, not gas this time but stars themselves, share the same plane and rotate in opposite senses with a poise that borders on theatrical. This is not the messy aftermath of an argument. It is a stable, symmetrical settlement reached long ago. The light from one population carries a slightly different age and metallic accent than the other, as if two choirs were trained in neighboring towns. Here, the counter-rotation is not tacked on at the edges. It is the spine and the mirror of the galaxy. You can almost hear the verdict the system hands down. A prolonged period of balanced assembly brought equal mass streams in opposing directions and stacked them into twin, razor-thin cities of stars. Nothing about this is timid. It is a sustained act of patience written in orbits that never touch. The screen switches and NGC 4826 drifts forward, the black eye, a spiral with a bruised lane of dust near its bright heart, and a secret that lives in the gas. The inner disk and the outer reservoir do not agree. The inner flow moves one way, the outer stream insists on the other, and where the two meet, a shock ring smolders, lighting pockets of star formation like street lamps down a contested boulevard. The chemical story confirms the split. The gas beyond the interface carries a leaner metallic signature, the kind that points to external supply rather than long, native enrichment. You are watching a galaxy drink from two directions at once and turn that contradiction into newborn clusters. The wrong-way motion is not an abstract. It is a factory that forges stars precisely where the shear bites and the clouds are forced to yield. Then the projector throws a curveball and paints NGC 4622, a face-on spiral that smiles while breaking the rulebook. Trace the arms with your finger. They point into the motion rather than draping backward. Leading arms, a geometry so rare it feels like a magician pulling a banner against the wind. The near and far test with dust settles the orientation. The Doppler colors confirm the direction. The arms do not trail. They lead, bold and unapologetic. To arrive at this pattern, you need a recent gravitational nudge that inverted the phase of the spiral density wave relative to the underlying rotation. A temporary choreography where the melody outruns the beat. You are looking at a fossil snapshot of a tide that did not merely stir but reset the rhythm. It will not last for ages, but while it lives, it tells you that spiral structure itself can be flipped by the right encounter, leaving a photograph of the moment when the rule bent. The lights dim and rise on a pair, NGC 5719 stalking beside NGC 5713. Partners in a dance that leaves one of them rewritten. In long slit and integral maps, the stellar field of NGC 5719 bears a colossal counter-rotating component. Not a fringe decoration, but a massive, extended disk built from gas that once orbited the pair as tidal debris. The other galaxy, gas-rich and prone to shedding under the pull, donated the raw material. The recipient turned the gift into stars that now wheel against the older population with the confidence of natives. This is a case where the mechanism has witnesses. Tidal arms visible in deep images, bridges of gas drawn thin between the pair, and a kinematic story that stitches the pieces into a single crime of passion. You do not need to imagine rivers in the dark. Here the river ran through the street, and the record still holds the puddled light. Now the silhouette of NGC 4650 steps forward like a challenge coin laid on a table. A polar ring galaxy is misalignment made architectural. The host wears the look of an early type, a bright central body with little gas of its own. Threaded through it at near right angles is a luminous ring, or in massive examples, a full star-forming disk, blue with youth and threaded with H2 knots that mark ongoing birth. Put a velocity field on the scene, and the axes cross like swords. One component sweeping one way, the other circling on a perpendicular plane, both with clean rotation curves and both long-lived under the halo's gentle but persistent torques. The ring's chemistry leans young and relatively metal-poor, as expected if it accreted from a captured companion or a cold stream. And the morphology is so blatant that even a glance reveals the rebellion. No subtlety here. Two cities in one gravity well, ignoring one another's traffic laws and yet sharing a single self-consistent potential, as if this were the most sensible compromise in the universe. Case by case, a pattern of consequence sharpens. Whenever the wrong-way motion reaches across gas and stars, the interface becomes a kiln. Rings of star formation are not decorative. They are pressure maps where opposing flows collide and squeeze the medium to ignition. Where the reversal lives only in the gas, metallicity gradients often invert, a signature of fresh, low metallicity supply reconstructing the outskirts against the will of the older, enriched interior. Where bars have metalled, the decoupled cores retain boxy isophotes and elevated velocity dispersion, the heat of their renegotiation still trapped in the architecture. Where clusters have stripped and refed, long wakes and jellyfish tails betray the trajectory, while reaccreted disks cut clean in a sign opposite to what the surviving stellar scaffold remembers. You notice something else while the gallery scrolls past. None of these systems has repaired its past completely. Warps hang on like a twist in old timber. The outermost hydrogen still wobbles along a plane closer to the halo's preference, hinting at a slow, relentless tug that never pauses. Thickened disks keep a low rumble in their line profiles, the spectral memory of agitation that heated the orbits. Even when order returns, it is an order that whispers about the bargain that produced it. A wrong-way galaxy never looks careless once you have learned to read the scars. Stand back from the parade and let the question rise in your chest. If each case reveals the culprit with this much clarity, the twin stellar cities in Virgo, the split-flow spiral with its bruise and its shock ring, the leading arm iconoclast, the tidally remade pair, the right-angled ring that flaunts its oath. What happens inside the engine once the flip is underway? And how does a city of stars live day to day with traffic that refuses to agree? The first consequence announces itself like two tides colliding in a narrow strait. Along the seam where opposite flows brush past, the gas does not glide. It rips, curls, and compresses. Shear stretches clouds into silver ribbons, then folds them back on themselves until their own weight becomes unbearable. Shock fronts flare. You can trace them as luminous arcs, ring-like firebreaks stitched with young clusters, each cluster a verdict delivered by pressure. If you could ride one cloud through that boundary, you would feel the jump, temperatures spiking, molecules rattling apart, then recombining as the post-shock gas cools and sinks into star birth. What looks like contradiction on a velocity map is, on the ground, a factory line where turbulence is hammered into order. Not all gas survives the crossing. Some of it is shredded into filaments thin as thread and flung into eddies that circle the fault, feeding a storm of small collapses. The magnetic fields that thread the disk are drawn into taut cords, draped and pinched by the shear until they guide the flows like rails. In their grip, charged particles skitter and glow, writing faint signatures of the stress that a quiet image would miss. The ring of star formation that appears at the interface is not a coincidence. It is the place where arguments become children, bright, short-lived, and loud. Chemistry records the upheaval with the patience of stone. Freshly accreted gas often arrives lean, carrying fewer heavy elements than the native reservoir that has been seasoned by many cycles of star death. When such gas wins territory in the outskirts, the usual gradient falters. Metallicity can dip outward, a bruise in reverse, the chemical equivalent of changing a river's source. Spectra of H2 regions along the counter-rotating ring will sing in a different key. Oxygen lines modest, nitrogen lines subdued, while the inner, older neighborhoods keep their richer accents. The flip has not only reoriented motion, it has rewritten the pantry, and young stars born on the wrong way lanes will wear that difference for as long as they burn. Realignment is not graceful. Gravity wants the disk to point the way the halo prefers, and the halo does not forget. Torques tug on the misfit components relentlessly, the way a current leans on a floating log until it swings broadside. The response is a long, slow groan. Warps persist at the outskirts like a vinyl record softened at the rim, and the turning surfaces inside the galaxy tilt and precess, each ring arguing with the next about which axis deserves allegiance. This dance can last for billions of years. Tilted planes slowly talk to one another through gravity's quiet voice until compromise thickens the structure and the sharpest misalignments blur into an uneasy truce. While the edges argue, the center sharpens its appetite. Gas fighting its way against the prevailing rotation loses angular momentum more readily. Collisions are not glancing, they are headwinds. In that resistance, inflow gains the upper hand. Material spirals inward along crooked, shocklit lanes. Each bend attacks paid in momentum, each kink a step closer to the nucleus. Bars, if present, tighten their grip, hauling gas across resonances where orbits change families and the traffic pattern tilts toward the core. Down in the dust-choked central few hundred parsecs, streams collide from opposing sides and settle into compact, lopsided disks that feed the black hole with a steadiness the quiet years rarely achieve. Outbursts follow. Jets or winds punch cavities. Cones of ionized gas lean out from the nucleus like searchlights in fog, and the whole central architecture bears scorch marks in line ratios that any spectrograph can read. Stars feel the disagreement differently. They are too collisionless to shock, but not immune to heat. Encounters with transient spirals and the grain of the counter-rotating mass field pump random motion into orbits the way potholes roughen a road. Velocity dispersion rises. Thin disks gain thickness. The neat parabola of rotational support surrenders a little to a hotter, more spheroidal stance. Box-shaped isophotes show up in the inner light, a geometric tell that something has stirred the city from planar grace toward a thicker compromise. Over time, this heating can drive a spiral toward the lenticular look. Arms muted, dust quieter, rotation still proud but less dominant, like a river slowed by gravel. Inside a kinematically decoupled core, the physics turns intimate. There, stars loop on orbits that are mirror images of their neighbors just a few hundred light-years out. Families of closed paths crowd near resonances, and small shifts in the potential swap passengers between them. The result is a central city with its own clock, insulated enough to keep its sense of direction while the suburbs keep theirs. Line strengths in the core hint at slightly younger ages or altered alpha element balances, depending on the inflow history. Signs that gas once pooled there, formed stars under high pressure, and left a population with a different biography. Watch long enough, and you see the coupling across the boundary. Weak bars tug, oval distortions breathe, and the two clocks exchange a little time. On the polar stage, the consequences writhe in 3 dimensions. The ring or polar disk lives near a right angle to the body, and every orbit feels the off-axis pull of the other. Precession becomes the background hum. The nodal line crawls. Gas streams thicken where they cross the host's minor axis, and ring segments brighten into beads as local compressions drive star formation in knots. The structure can be surprisingly durable, protected by the halo's shape and by the ring's own self-gravity once it grows massive. Still, each turn chisels at the alignment, and faint flares or corrugations reveal the tireless hand trying to sand the system back toward a single plane. All of it leaves fingerprints in the faint light beyond the comfortable brightness of images. Deep exposures reveal shells, ripples, and tidal ghosts, the low surface brightness residue of the events that flipped the spin. These features are not decoration, they are receipts. Shells arc like tree rings around the host, timing past accretions. Stellar streams loop in pale ribbons, still orbiting along the original plane of the intruder long after the gas has settled into a contrary disk. In the outermost hydrogen, where the galaxy breathes and whispers, you can track the slow rephrasing as the halo's torque tries to rewrite the opening sentence. You might expect such turmoil to fade into forgetfulness, yet the dynamics keep asking hard questions. How much counter-rotating mass is enough to tip the balance from ring-limited skirmish to wholesale regime change? How bright must the central engine burn before its feedback scours the very lanes that fed it, cutting its own supply lines? How long can a galaxy keep 2 clocks running without one winding down the other? Stand in the dark with those questions and watch the velocity colors flicker on the screen. The arrows do not agree, and in that dissonance something vital is being decided that the maps have only begun to name. The sky widens into census, and the single shocking case becomes a low drumbeat heard across thousands of targets. Observatory domes blink like watchtowers, and each night adds another confession to the archive. You can feel the shift from anecdote to statistics. Not a freak accident, not a single overturned cart on a quiet road, but a pattern braided through the cosmos. Early type disks, the lenticulars with their smoothed faces and disciplined light, stepped forward in surprising numbers with kinematic misalignments between stars and gas, as if the calm exterior were a mask for long negotiations. Pure spirals admit the trick less often, yet when they do, their defiance is luminous, easier to catch, harder to forget. No one calls this common. No one calls it rare enough to ignore. It lives in the middle ground where nature keeps her most instructive secrets. Environment sharpens the relief. Out in the field, far from crowds, many galaxies keep the promise of steady supply. One main filament, one coherent spin, long piece. Drift inward, into groups where neighbors are near enough to tug, but not dense enough to strip all softness away, and misalignments bloom like wind-bent grass. Closer still, in clusters where a hot medium leans like a gale against incoming disks, the wrong-way signatures gather around the edges and in the wakes. Ram pressure tears away gas. Tides shake the spine. Reaccretion writes new lanes with contrary intent. It is not fate but probability. Where encounters multiply, so do reversals, and every statistic you calculate picks up the scent of place. The cosmos has its rough neighborhoods, and spin remembers the street. Simulations take the witness stand next. They begin with a baby universe and grow it forward under gravity, hydrodynamics, and the feedback of stars and black holes. When the code has been made to breathe, theorists draw digital surveys from their model skies and weigh them against what telescopes see. The leverage is not only in matching shapes or sizes, it is in matching the correlations. Do simulated disks flip more often in groups than in the field? Do the ages and metallicities on the wrong-way lanes echo the chemical poverty of fresh supply? Do polar structures survive for long spans under halo torques that never sleep? Each yes tightens the weave between idea and evidence. Each no bites like cold air and forces a new pass through the physics. Beneath those comparisons lives a deeper test: the choreography of spins with the cosmic web. Filaments do not merely feed, they guide. In many simulations, halos tend to align their angular momentum with the threads that nourish them, a tendency that shifts with mass and time. Take a wide enough sample in the real sky and measure the angle between a galaxy's spin and the local filament. Then count how often the wrong-way signatures occur along bends, nodes, and crossroads. If the counts agree with theory, you have traced the fingerprint of the web's scaffolding on living disks. If they do not, some quiet term in the equations is louder than you thought. You are not only learning how galaxies flip, you are checking whether the invisible skeleton of dark matter has left the marks it should on the flesh of light. Instruments turn the screws with fresh reach. The James Webb Space Telescope pulls back the veil on dusty cores where countersignatures hide, seeing inner disks and compact rings that ground-based optics once smeared into anonymity. Deep radio arrays, precursors and pathfinders to the square kilometer array, along with dishes like Meerkat, chart neutral hydrogen to astonishing faintness, following outer warps until they fade into the night and revealing flips far beyond the stellar cutoff. Optical and near-infrared spectrographs with integral field units paint velocity fields across entire faces in a single exposure, and new detectors hold the line in stability long enough to pry out subtle misalignments that would have drowned in noise in earlier decades. On the horizon, extremely large telescopes promise starlight maps of faint halos where tidal ghosts carry receipts for ancient acquisitions. Each shell and stream a breadcrumb leading to the moment the sign of motion began to change. With better eyes come cleaner demographics. Surveys that once relied on bright inner disks now reach the outskirts, where wrong-way gas likes to settle and quietly reorder the ledger. The picture mutates from a binary question into a spectrum of cases. A slight tilt sustained by a recent nudge, a sharp outer reversal born from misaligned inflow, a full counterrotating stellar disk assembled patiently over long ages, a polar ring so massive it behaves like a second city. The statistics begin to stratify by mass, morphology, and neighborhood. Spin is not a single story. It is a family saga, and the contradictions sit at the same table as the agreements. You might expect the lesson to be neat. It is not. Every new layer of precision reveals a corner case that refuses to fold into the trend. A spiral in a lonely field with a crisp, young counterrotating gas disk and no obvious culprit in sight. A group central with a placid face and a stellar core that turns against its own halo while the surrounding satellites keep to a common wind. A polar structure whose chemistry reads like native birth rather than foreign import, as if the host itself learned to breathe in two directions. Each outlier tempts the mind toward invention. Each insists on patience until more evidence arrives. What do these systems teach you, not as curiosities but as instruments? They turn misalignment into a ruler. The frequency of flips constrains how often gas arrives along new planes. The mass in counterrotating stars sets limits on the longevity and throughput of those planes. The geometry of polar rings tells you about the shapes of halos, because only certain potentials can keep those audacious structures coherent across many orbits. Even the pace at which wrong-way features fade becomes a clock, measuring torques and dissipation that are otherwise invisible. In the long account of galaxy growth, they annotate where the quiet flow failed and where the neighborhood intervened. And then there is the human angle, the way these findings loosen your grip on a tidy cosmos and replace it with something truer, something alive. You begin to look at every orderly spiral with a second sight, wondering what contradictory lane might be whispering at the edge in radio, what decoupled core might be turning in the dusk at the center, what filament might be drifting toward a different orientation just beyond the reach of today's maps. You start to hear the universe not as a metronome but as a polyrhythm, steady pulses overlaid with crossbeats. A score that only resolves if you listen long enough and wide enough. Stand with that sound in your chest and answer this without haste. If a galaxy can carry two histories at once, How many can a universe hold? And what else is written in motions we have not yet learned to read?